Good day, everyone. Here's a quick question I'm going to take from the Pearson grade 11, grade 12 book. And this question is from page number 335, 535, shall I say, 535. And this is the question number 2. And in this question, we are given that four charges spheres with an equal charge of 2.2 coulomb are situated in the position forming a rectangle as shown in the figure. Determine the net electrostatic force on the charge at the top right corner. So this is where I wanted to find the net force. So again, I'm going to draw the diagram here so that I can draw some vectors on top of it. So these are the four charges given to me. Each charge is 2.20 coulomb, and this one is 2.202, this one is 2.20, this one is 2.20. And on the charge C, I wanted to find the net electrostatic force. So the distance is also given to me between the two charges. All the charges is given to me, shall I say. So this one is 0.3 centimeters, so 0.3 is centimeter, actually 30 centimeters, which I can call it as 0.3 meters because 1 meter is equal to 100 centimeters. And this one is 40 centimeters given to me, 40 centimeters, which I can call it as 0.4 meters. Now, if I start solving, let me mark them. This one, I'll mark it as A, B, and this one C and D. So I'm going to start finding out the forces, force exerted by different charges on charge C. So I will first of all find force exerted by B on C. So that will be equal to K Q1 Q2 divided by R square. This is the formula I'm going to use. And then K value is 9.00 times 10 raised to the power 9 multiplied by Q1, which is 2.20, multiplied by Q2, which is 2.20, divided by the distance between the two charges B and C. That is equal to 0.3, and I will square this number. Now, once you're going to do the calculation for this one, you're going to get the value as 4.84 times 10 raised to the power 11, and the unit of force is always Newton. So one thing I want to tell you, if you are confused how to put it in calculator, I'll show you one more time here. So you're going to start it by starting with the bracket 9.00 times 10 raised to the power 9 multiplied by 2.20 multiplied by 2.20, close this bracket, start and then divide, and then start another bracket and put to 0.3, close this bracket, and then square it. And once you're going to put this way in the calculator, you're going to get this value. All right, so this was B on C. So same way, I'm going to try and find out what is the force exerted by D on C. So if this is 40 centimeter, so this distance will also be 40 centimeter because it's a rectangle. So this is 0.4 meter. I can write it here. So here FD on C will be equal to, these are the two I am taking. So D on C will be equal to 9.00 times 10 raised to the power 9 multiplied by the two charges 2.20 times 2.20 divided by R square, and the distance is 0.4 square. Again, once you're going to do the calculation, you're going to get the value as 2.72 times 10 raised to the power 11 Newton. So this force is towards the right hand side, and this force is vertically upward, the direction of this force, because B on C, if I clearly see, B on C will try to push it in the upward direction, or these are positive charges. This is positive, this is positive, and this is positive. That's given to me in the question. And D will try to push it towards the right. And now I also wanted to find out how much force will be applied by A on C. So this distance is 0.4 meter, this distance is 0.3 meter. So if I apply the Pythagorean theorem, 0.3 square plus 0.4 square, that's going to give me AC equal to square root of this. I'm just applying A square plus B square equal to C square. So because this is a right angle triangle here, being a rectangle. So AC value will come out to be 0.5 meter. So this is 0.5 meter. And now I can also find out the force exerted by A on C. So FA on C value will be equal to 9.00 times 10 raised to the power 9 multiplied by 2.20 multiplied by 2.20 divided by 0.5 square. And once you're going to do the calculation, you're going to get the value as 1.74 times 10 raised to the power 11 Newton, and that will be inclined at an angle. So because if I see this is a tapered line, and this force gonna look like this. Now because this force is at an angle, I need to find out the force for this angle also, this theta. So this theta will be equal to this theta. So if I can find this theta, I'll be able to figure out this theta also. So tangent theta is equal to opposite upon adjacent. So that's going to give me theta equal to tangent inverse 0.3 divided by 0.4. So theta value will come out to be approximately 36.9 degrees. So this angle is 36.9 degrees, and then this angle will also be 36.9 degrees. Now I will try and find out the component of this green vector in the x and y direction, because only then I'll be able to find the resultant vector. So in this direction, the component of the green vector, and this direction, the component of the green vector. So this value will be equal to, because this value came out to be, if I see carefully, 1.74 times 10 raised to the power 11. So this was 1.74 times 10 raised to the power 11. So this value will be 1.74 times 10 raised to the power 11 cos of 36.9 degrees. And this value will be 1.74 times 10 raised to the power 11 sine of 36.9 degrees. So I'm going to write it here, the components of this vector. So this is at an angle of, uh, as I said, 36.9 degrees with respect to, I can say, north of east, right? Now, so FA on CX component, that will be 1.74 times 10 raised to the power 11 cos of 36.9 degrees, and FA on C Y component value will be 1.74 times 10 raised to the power 11 sine of 36.9 degrees. Make sure your calculators are in degree modes while calculating these numbers. So this is 1.39 times 10 raised to the power 11, and sine component value will be 1.04 times 10 raised to the power 11 Newton. All right, so I figured out the x components and y components. So this one is an x component, the blue one, and then this one also. How much we calculated? D on C. D on C was 2.72. So 2.72, or I can write it as FD on C plus FA on CX. So that'll be equal to, D on C was 2.72 times 10 raised to the power 11 plus 1.39 times 10 raised to the power 11. Now I'm gonna try and do the calculation on my calculator. So 2.72 plus 1.39, that comes out to be 4.11 times 10 raised to the power 11. So this is F net X. F net X, this is on C. All right, so F net Y on C, net Y on C, that'll be equal to the other two. The other one was, I guess, B on C. Yeah, B on C. This is Y component, B on C, plus F A on C Y component. So that'll come out to be 4.84 times 10 raised to the power 11 plus 1.04 times 10 raised to the power 11. That's what we figured out earlier. So this is Y component, and this one was in the upward direction. So now if I add these two numbers, 4.84, 4.84 plus 1.04, that comes out to be 5.88 times 10 raised to the power 11 Newton. So I figured out both the components. One is y component, which is 5.88 times 10 raised to the power 11. And then I figured out the x component also. That was 4.11 times 10 raised to the power 11. And now I have to find the resultant, and you know better than me by now how to find the resultant vector. So this will be 5.8 8 times 10 raised to the power 11. So a square plus b square. This is f net on c. So f net on c value will be equal to square root of 5.88 times 10 raised to the power 11 square plus 4.11 times 10 raised to the power 11 square. So again, I'm going to do the calculation on my calculator and see what's the value I got. 5.88 square plus 4.11 square, and then I will take the square root of this number, 7.17. 7.17 times 10 raised to the power 11 Newton. F net on C, and then I can also find the angle tangent theta, which is equal to opposite upon adjacent, which will be equal to theta equal to tangent inverse. You're going to put 5.88 times 10 raised to the power 11 divided by 4.11 times 10 raised to the power 11. Theta value will come out to be approximately 55 degrees north of east. Hopefully you were able to understand this question. I will highly encourage you guys to try and do all the questions on page 535 and 534. Okay, so let me know if you guys have any questions. Email me, please. And yeah, that's it for today's class. And I'll see you with another lecture video. Bye now.